Good morning, 8th grade science students. This is Mr. Ducharme. Welcome to week 3 of 8th grade science e-school. Today we're going to start learning about chemical reactions. Quick note before we get started. Last week you learned all about chemical formulas. You learned how to write them. You learned how to analyze models of them. You learned how to make your own models of them. It's going to be really important that you know that information. We're going to be bringing that all back together with what we learned this week on our third module of this week. Okay, so you'll notice that we're going to start doing some slightly different things in 3.1 and 3.2, but on 3.3 we're going to bring both of those ideas together. So really important you have completed that work and you've done it to a high quality so you're able to continue learning and building on your understanding with us. Today's objective is that you're able to write a chemical equation from a sentence description and analyze the reactants and products of that equation. Let's dive in. Chemistry joke of the week, thanks to everybody who sent me their answers to the first one. Once again, no Googling. Try to think of the answer before. Email it to me at ben.ducharme@scienceandtech.org. This week's joke is making bad chemistry jokes because all of the good ones, ... Finish the sentence, email it to me, and I'll let you know the answer in our third module of this week. All right, quickly, I'm going to open up your document because I want to show you a few things before we get into our guided notes. Okay, I first wanted to show you today's do now is slightly different than things you've done before. It's asking you to look up your mastery check scores and fill out an analysis. Now, different teachers are going to tell you different instructions for how they want you to do this, but I want to make sure that you reach out to your teacher if you are confused about how do you do that. We're going to start doing that every Monday to reflect on the past week's success or lack of success in the mastery checks. So really important you learn how to do that this week so you know how to do it in future weeks. If you are confused or have questions, reach out to your teacher right now. The second thing was today's Explore. You had to watch 2 YouTube videos. Okay? So at this point, you should have already finished watching both videos, and you should have filled out your observations, things you see. You should have also filled out the analysis questions because we're going to use that today as we get to our guided instruction and guided practice. I wanted to show you those things. Let me jump back over to notes, and let's keep learning. All right, let's start with guided instruction today. So last week, we learned how to write chemical formulas, which was one way that scientists communicate information about chemicals that are too small to see. Today, we're going to learn a different formula or different equation that scientists use to communicate things about change. We're going to teach you how to use that formula today. Tomorrow, we're going to show you how to understand what's happening when you're reading that type of equation. And then on the last module of this week, we're going to start to use chemical formulas to actually understand what's happening in those at a microscopic level. So, scientists use common symbols to represent how compounds change. They write change using a chemical equation. Go ahead and type that into your notes. There are 3 parts of a chemical equation. First, there are the reactants. That is the substances you start with. Okay, so everything you begin with is what's called a reactant. The second part of a chemical equation is the arrow. The arrow shows that the reactants are changing into something new. So the arrow, whenever you see the arrow, it means some sort of change is taking place. The last thing are the products. The products are the substances you end up with or that are produced in that equation. So reactants are what we start with. The arrow shows change, and the products are what we end up with. The way I remember this is RIP, reactants into products. So if you're ever confused about where the reactants, where the products, think about that, RIP, reactants into products. All right, let's jump over into guided practice. Okay, we're looking at guided practice together. Number 1, think back to video 2 you watched during the Explore section. Describe what happened in the video as a sentence, and then turn that into a chemical equation. Wow, okay. So first, I'm going to re-show the video number 2, which was the ice cube melting on a stove burner. Seems pretty straightforward. I'm going to go ahead and pause right there. Let's describe what we saw as a sentence. So what I'm going to say is a solid ice cube changed into liquid water. That's my one sentence description of what just happened. Now we're going to take that sentence and we're going to write it as a chemical equation. We're going to use the same formula that scientists use to write out the chemical equation. So let's first think about our reactants. A reactants, remember, is what we started with. So we started with an ice cube. Now, ice is water, okay? So we're going to actually say it is water, but it's solid water. And what scientists use to communicate whether something's a solid, liquid, or gas is they put a parentheses and they put an S for solid in those parentheses. That tells us that the thing that comes before it, water in this case, is a solid. So that's our ice cube, is solid water. Then we're going to draw an arrow. You can do this by putting 2 dashes and then a greater than sign. If you hit space, it turns it into an arrow for you automatically. Once again, to draw an arrow, you can put 2 dashes and then a greater than symbol, hit space, and it turns it into an arrow automatically. So we had solid water, our ice cube, and then we ended up with liquid water. So water, but I'm going to put parentheses and then an L and then a closed parentheses to show that that is liquid water. That is that reaction we just watched in the video written as a chemical equation. Any scientist could read that and tell you exactly what it was. They'd say, oh, you had some solid water, or some solid ice, and it changed into liquid water. Great, easy. Now the reactants in that equation, reactants, remember, is what we started with. So everything before the arrow is our reactants. So our reactant was solid water, or you could have written ice. That works as well. What was the product in this equation? Well, the product was what we ended up with, everything after the arrow. So that was liquid water. Okay, that was a pretty straightforward example. Let's get a little bit more complicated as we move into our next example. Our next example asks us to analyze the sentence below and then write it out as a chemical equation. Oxygen gas and methane gas react and change into water vapor and carbon dioxide gas. Okay. This time I gave you the arrow in the middle. So let's start with our reactants. We're going to click so we're on the left of the arrow. Well, we have oxygen, and I'm going to write parentheses, G, parentheses, and methane gas, methane as a gas. So oxygen gas and methane gas react and change. Aha, change is my clue that that's where my arrow goes. Remember, our arrow represents that something's changing. So it's changing. So now I'm going to click to the other side of the arrow, the right-hand side. And now I'm going to figure out what my products are. They change into water vapor. Water vapor is just water as a gas. It's like steam. And so I'm going to put a plus symbol, and carbon dioxide as a gas. Okay, so now I have oxygen and methane in my reactants, and I have water as a gas, that's water vapor, and carbon dioxide gas in my products. Now notice, water vapor and carbon dioxide are two separate things. So just like you learned last week, when you have a mixture, is we're going to use that plus symbol to separate those two terms to show that they're two separate things mixed together. Okay. Part A tells us to highlight the reactants in yellow and then highlight the products in green. So I'm going to highlight all of my reactants, so everything before the arrow, that's a reactant. And then I'm going to choose my highlight tool, and I'm going to change that to yellow. And then after the arrow, I'm going to highlight water, vapor, and carbon dioxide gas. And it tells us to change the products to be highlighted in green. So I highlighted everything after the arrow. So once again, a scientist could come along and tell you, okay, in this reaction, in this chemical equation, you started with oxygen and methane gas, and they changed into water and carbon dioxide gas. Great. So instead of having to type out these long sentences, scientists can communicate information really quickly with these chemical equations. All right, one last version of this is what we see in number 3. It tells us to analyze the chemical equation below and rewrite it as a sentence. So now we're working backwards. Okay, so first let's start with our reactants. sodium as a solid and chlorine as a gas, and then I have my arrow, which means changed into salt as a solid. Let's type that out as a sentence. Solid sodium and chlorine gas changed into solid salt. Okay, sounds good so far. What are the reactants in this equation? Well, everything before the arrow. So I started with sodium as a solid and chlorine as a gas. What is the product in this equation? Well, what did I end up with? I ended up with salt, which is a solid. Okay, those are 3 example practice problems of how to set up a chemical equation, how to write out solids, liquids, and gases, and how to analyze a chemical equation to understand what it's telling us. I want you to go ahead and move on to the check for understanding. Pause the video right now. We're going to go through the answers in a few moments. At this point, you should have completed your check for understanding. If you need more time, hit pause in this video. Complete your check for understanding independently first. Once again, it's critical that you are able to get the practice first so you know how well you're doing before you attempt to complete independent practice. So, instructions to sentence number 1 told us, write it as a chemical equation. So the sentence was, wood is burned, changing into ash and smoke. Okay, so think about a campfire. We start with wood, and that changes into ash, what's left in the campfire once the fire is done, and smoke, which leaves and goes up into the air. So here's what I wrote as my chemical equation. I had wood, which is a solid. I put my arrow, changing into ash, which is a solid, and smoke, which is a gas. Then it told me to highlight the reactants in yellow. So my reactants are wood. That's what I started with. My products were in green, ash and smoke, what I ended up with. Go ahead and give yourself a score out of 4. 1 point for getting wood as your reactant, 1 point for ash and smoke as the products, and then you got a point for highlighting the correct things in yellow and green. Give yourself a score out of 4. After this, you're moving on to independent practice, practicing the exact same skills, and then you're going to go ahead and take the mastery check for today, which is called 3.1 Intro to Chemical Reactions Mastery Check. We'll add lots of more information and difficulty onto this starting tomorrow, but really critical today that you are able to analyze a chemical equation and write your own using the correct symbols that scientists everywhere use. Thanks for watching, and I will see you during the next module.